So tonight we're going to learn how a digitalized plant design workflow is done with the use of intelligent plant design software. Our guest technical lecturer or sharer, he is an experienced piping and mechanical engineer and the go-to person for plant product training, consulting, and configuration services in Southeast Asia, Australia, and New Zealand region. Let's all welcome Engineer Alvin Losala.
Good evening, Elsie. Good evening, everyone. First of all, thank you for inviting me here. Yeah, this is a big pleasure na makasama ko kayo, and especially it's the first time I'm speaking in this community. Um, my location right now, I'm in Singapore, so I'm actually based in Singapore, and I'm handling the regions of Southeast Asia and helping the New Zealand and Australia region as well. Okay, so let's get started. Okay, so good afternoon, good evening, and maybe good morning, everyone. For if we have attendees coming from any part of the any region in the world, so good morning also. So for my fellow Filipinos, yeah, Filipino engineers, good afternoon and good evening. So first of all, I am very grateful and thankful that I am invited in this event to speak to you and to share the technology and the knowledge of what I gained from my experience of working in a software company like Bentley System. So my topic for today is basically focused on the solutions or something like a workflows that you can um, use in such a project like a planned project. So I have a sample data set here, something like a wastewater project, which is one of the major projects that we are building right now in this region. So I hope that you will learn a lot from today's session. And okay, so first is the the agenda for today. I prepared for you a little bit of the introductory part that was introduced by Nelsie. So thank you, Nelsie, for the introduction. Second is I'm going through the basic workflows within the life cycle of a plant project of the assets of plants. So let's understand there what are the current issues or problems we encounter when we are doing a plant project. And then let's jump it right away into the different plant design workflows. So, but before that, I will give you a brief introduction of a digital twin concept. So, because all throughout the process, we will be talking also the digital twin platform because the technology that Bentley brings is leveraging the iTwin platform also. Okay, so again, this is me, Alvin Lasala. As Nelsie has mentioned, I am based in Southeast Asia and I am working in Bentley Systems since 2019. Okay, so first of all, just giving a brief history of you, where this digital twin came from, where the BIM came from, where the CAD came from. So we all came from the drafting principles. So when we started our engineering projects way back in 80s and 90s, we don't have enough access to the technology. So we used to do the drafting kind, where we used to do um, the hand manual method. So then comes to the technology where the computer aided design was introduced. Then we started using different CAD applications. And then way back around 10 years ago, BIM or the Building Information Modeling was introduced to us, which gave us a better workflow or a better guide or process to build our asset that includes the information of your model. So, and the latest technology now is the digital twin. So this is something like the combination of your engineering technology, the information technology as well as the operations technology. So this is something that we will touch a little bit in this afternoon. Looking at the current challenges of the different industries or different companies, so we are facing some of the challenges. So I just listed a few here. I will start with the first one. So the information that we get from the models, especially the owners and operators, when they submit the design, so some of the time, most of the time, this is not that kind of complete information that you can get, especially if you're an owner or operator. So you need a model that, as much as possible, will give you the best or the most information about your asset, about your model. So this is one of the issues that is ongoing. So another one is the coordination between members or the teams of the project. So if you have a project which has members working together in a global or a distributed community or a distributed team, so where you don't have a single or something like a common office to work with, so we are working online. So this is a little bit of a challenging, especially on the current situation we have. So then the third one is the availability of the data. So when we are working on a big or large project, we normally need to access information at any stage of the project. So if we don't have the proper workflow, such as the BIM, we it's very difficult to get the most available data or the most recent data or up to date data. Okay, then meeting with tight schedules, basically that is addressed if we are using an intelligent software. So we can really be more productive if we are using uh, intelligent solution. Then lastly is all throughout of this is difficulty in capturing the project cost of the project. So if you don't have the best the correct workflow and modeling your planned project, so it's really challenging to capture each of the materials that you need to purchase. Okay, so that's some of the challenges that we have now. So so going through the initial stage of the life cycle of the project, so I just give here to you the workflows of an asset of a planned project. So each of these are some of that I listed. Maybe there are still that is missing here, but basically this is the concept that we look when we are working with a planned project. So our project is also measured. The success of our project is also measured by each milestone. We call it milestone of our project. So from front end engineering, then going to the issuance or the initial conceptual design, then purchasing or cost estimation, where you have the initial estimation of the cost or initial order of your purchase order, and then when you have this package completed, you can package it into different work package and tender into the contractors where you want to award it, and then followed with the contractor will work on procurement process and going to the building of it and construction, and finally hand over to the operator or the owner. So then as time goes on, when it reach out the turnaround or something like modification of the assets of or a lifespan of a specific asset, then there goes the modification of the project, and at the end of the lifespan of of the asset, then we need to decommission it so that we can put up another plant asset. Okay, so that is something like a complete asset life cycle. So just to give you a brief information on what are the different stages of a planned project. So so these are I also put it here, the asset life cycle. So if you can see this one, normally this kind of project requires something like a capital project is containing like huge amount of data. So if you imagine from front end engineering to commissioning on decommissioning and handover, so what we need to do is at least as much as possible, we need to bring in the information, or we have to collect the engineering information with all throughout the stages of the project in a common data environment where every information that you get from conceptual, you can reuse it going through the front end and estimation. And you can also access any information at any stage of the project. So this is what I intend to say here. So what we normally give the solution that we give here is basically a common data environment. We all know that there are different vendors or different kind of application that can be a common data environment. So I'll just give you here an example of of the the situation where you can basically use the common environment. So just imagine here, from the bottom side, you have a distributed project, a global project, where your different actors of the project and different stakeholders is located at different regions. So what I meant to say here is each of these stakeholders need to access the data, because when we are transmitting documents from one stage to another, so it needs to be digitally accessed by each of the stakeholders. So design office is located in different location. The fabricator is in a different region. Then you have the construction site and another in another region. So that's what I intend to explain here. It's the availability of the data that you can access when wherever you are. So that will require a common data environment kind of solution. And moving forward is the digital concept. So so the common data environment that I in the previous slide I explained. So another something like a higher level of collection of data is the introduction or the working with the digital twin. So when the digital twin came out, so it attracts a lot of attention because of this new technology. So what we meant to be with what we mean when we're talking about digital twin is it is the something like a digital representation of your physical asset, where this asset or digital asset is continuously updating and changing at any stage of that asset life cycle. So this digital twin is also the combination of the engineering information, your operations information, the data that you get from the operations, as well as the information about your assets. So this will make sense. Your digital twin, you know, we need to make sure that this is up to date and continuously updating so that you can use this one for further usage. So I have a few here for visualization. You can use this one for your training purposes, clash detection, and so on. Then you can also monitor the change of the asset for like use of analytical and visibility, something like that. Okay, so the life cycle of the asset. So if you look right here, these are the different purposes or a different usage of the iTwin or a digital twin. So it spans to the entire asset life cycle. So at any stage of this, from planning to design to analysis and construction, as well as during operations and maintenance. So digital twin is the concept where you can you can leverage the digital twin at any stage of this project. So in today's demo or workshop, I don't know what to call it. So I will be focusing on the design stage. So how we leverage or with the digital twin during the design stage. Okay, so the design stage that I'm planning to show here is the different workflows during the working with the plant models, starting from the process and instrumentation diagram, and then going through the 3D modeler. So I hope that I can give you a little bit of an overview of what is available now in the Bentley solutions on what we have. Okay, so before we proceed, so apologies if I did not give the description of this. So plant site is the term we call as a digital twin service that we call for plant project. So later on, I will just give it to you. So basically, the digital twin concept is as a different application. So you can use this during the design stage. You can use the digital twin concept also in the building or construction stage, as well as operation and maintenance. So during the design stage, you can produce models and work it together with the digital twin, and you can continuously sync your data as well as visualize and do design review. Okay, so before we proceed with the applications, just give here to you the different sources of the data. So in an integrated plant beam model, so if as you can see here, we have different disciplines or different departments that's working together to build your uh, project. So from civil to you may have architectural drawings, your electrical and mechanical. So these are different maybe stakeholders or different departments of the project. So the challenge in this kind of project is because of this multidisciplinary plan project, you need to federate all of these models into a single format or a single model so that we can visualize and manage all of these models together. So from the output or a federated model, we can bring out or we can pull out the information. You can query the data from the model. You can also produce the drawings, your deliverables. You can also publish this model for the 4D simulation and construction as well as to the operation and maintenance. So by looking at the integrated plant beam model that I just showed to you, so so it's a whole concept that we always consider when we are building a plant project. So so right now I am showing to you the different softwares that we deliver we offer in Bentley. So we are in Bentley Systems. So we are a software provider of infrastructure applications. So whether you are working in an architectural firm or in a plant design firm or engineering firm, so you may be aware of the solutions we have. So we can see here from conceptual to going through the operation and maintenance, so we can see the different types of applications. So, but today I will be focusing only on the open plan products. Okay, so I'm just going through with the open plan products now. So basically, this is the suite in a plant kind of software. So whether from a different vendor, so it's still the same suite that they offer. So in Bentley Systems, we call it Open Plan Connect Edition. So it contains the different type of products, starting with the open plan PNID for piping and instrumentation diagram. Then for 3D modeling, we have the open plant modeler, and for the deliverables generation of the deliverables automatic generation, we call it open plan isometrics, and then the orthographics manager. So So being said that, at the center of the open plan suite is the digital twin concept. So where we are leveraging the digital twin as our database. So by the way, OpenPlant doesn't have a local database. You don't require it to use OpenPlant. So if you're working with a larger project, so you can leverage the digital twin concept, the digital twin by using the plan site services in digital twin. So basically, the open plan suite is the application you use to design your project, and the plan site or the digital twin services is the solution you will use to build, to construct, and to manage your project. So I will give you a a little overview of that later on. So moving forward to the basic workflow in a plant design. So normally it starts with the front end engineering where you define the process flows, define the work packages of the project, and then proceeded with the P&ID creation. So where you define the different type of piping material class, the standards that you will use, the the equipments, so and so on. And once you have this PNID model, then you can go ahead with working with your 3D model. So there are some prerequisites then in working 3D models. So some of that is building the catalogs and the piping material specs, uh, getting the data from the vendor because you have to bring it in into the 3D model as well. Okay, so your 3D model basically will produce the 3D structural, 3D equipment model, your piping model, your HVAC systems if you have, you can also work it, and then electrical systems. So these are some of the discipline that you will consider in a plant project. So then working with 3D models. So some of the deliverables are can be utilized for the analysis. So we all know that we require analysis for structural as well as for the piping analysis. And then once we have this assessment completed, we can now produce our deliverables such as your GAs, your bill of materials, as well as your isometric drawings for your piping. So this is basically the simple workflow in a plant project. So I have a video right here, but instead of playing this one, so I think we have enough time to show to you the actual application live. Okay, so hi Nancy, are you there?
Yes po.
Okay, so let's proceed with the applications. Okay, so we'll start with the open plan PNID. So as you can see in my previous slide, where is my slide? There you go. Okay, so going back to the plan process, so I will be starting with the PNID. I just give you a little brief introduction about the interface of the open plan PNID. So I will launch it from my application. So while it is launching, so I am opening in my browser right now, Google Chrome browser. I am opening a digital twin project. So a digital twin project that I am using while I am in the engineering stage. So basically, this is something like you build or you federate during the design stage. So in Bentley systems, we call it plan site. So this is the portal, PlanSite Bentley portal, where we house the project. So it is something like a repository of your project if you are using the OpenPlan products. So basically, in OpenPlan, you don't require a database. So I think it's a very unique software because any other software of any other plant software will require a database. So OpenPlan does not need it. Okay, so this is the homepage of the plan site, and then this is where we create the project, and then right here is the list of the projects that I have. So I'll give you a little brief of information right here. I'll just go into this specific project. Okay, so what you can see in the homepage right here. So there are different features of the plan site. So we start with the data manager, where you can manage your tags, you can edit, you can create, and you can update your tags here. And then you can produce queries if you want to query your piping or a bill of materials. If you want to query material list from a building information, from a civil information, you can query everything right here. Okay, so you can also see the different changes in the list of the change set. Basically, when we are working in a plan project, when we each time we update the plan site, it will store the information, or it will list down every change set. So basically, you can go to this change set anytime. You can visualize what has been changed at this specific timeline. Okay, so the change set will look like this if you look at the changes. So starting from the initial stage of the project, you can see it was created in March 21, then going through all the way. So the project is now at the latest date, September 17th. So all throughout the stage of the project, all of the change set is recorded, and you can visualize this by just clicking on this button. Okay, so but before I tick that, you can also create the versions of this. So I did not create one. So the name versions is for us to record a specific milestone of the project. So this specific milestone can be compared from an older milestone or to the latest milestone. So this is very helpful when we are doing design reviews. So I just quickly go uh, to the data manager first, and then just go to the tag management. Okay, so I have here opened in another tab the tag management feature. So data manager is, if you all know, if you are in a plant design industry, so basically the data manager is something like the heart of the plant project, because it is the database of your information. So it contains all of the assets that you created in a plant software. So this is how it looks like, where you can browse for the different classes or the different elements that is available in the project. Okay, so I just switch to my latest tab. So you can see right here in the equipment list, you can see the different subclasses or the child of parent class. So rotating equipment, pump, you can tick it, and then you can view the list of the data. So these are the pumps that I tick. So we have 38 items, and also this is the interface that we can create a tag. Okay, so for example, I will be creating a single tag. So this is just a button right here. You can just tick select the associated or the plant breakdown structure from plant area. Then you can put the device type code or the code that you use to specify a pump. Then I'll just put here 205 as the number. So you can see that the name or the tag information is automatically updated. So I'll just assign it to a specific service, and then to the specific unit. So the rest of the information containing operational and design information, we can just skip it when we are building a tag. Okay, so I'll just add this into our data manager. we can close it, and then you can review the tag that you created. So basically, this is the same concept if we are using different software. So if we are using a desktop software, it's the same concept. So I will review now the tag that I create. So it looks to be in the uh, PJ, that is a place in a dynamic pump class. Hold on, I'll just go back right there. Okay, where did it go? Okay, it was not a pump. I think I did not create the pump. That was wrong. So sorry about that. I'll just go right here and specify the specific item. Okay, I forgot to do it. So I'm going back here. Put the pump. And just put the 205. Okay, I hope my eyes is okay. So I just assign again the service and the unit, and then I will add it into my system. Then I close this, and then that's the 1A PMP205. Make sure we don't forget it, and we save it. So the the status is created. It shows here, and I will review my tag list. Then it should be showing here this pump now. This is the new pump that we created. So I'm doing it in a Google Chrome browser. And now, after I have created it in a browser, we can now use this tag information into our desktop application. So this is the simple workflow of that. So I will now go to my PNID. So this is OpenPlan PNID, by the way. So OpenPlan PNID is the application, the Bentley system's specific application to produce your 2D diagrams for process project. So basically right here is the same context that we need to specify the project that we are working. So we can also review the properties of this project. So you can see right here, it is connected to this demo water plant project. That is the same water plant project right here that I created. Okay, so right now I will open an example PNID to you. So while it is loading, let's go back to the plan site and just go let's go and open the visualization feature of this project. So for me to open the visualizer, so we have the button right here to visualize it, or we can also go to the change set. So meaning we need to, I'm using the changes for me to be able to see what has been changed or the latest change set. So you can see right here, the latest change set 300, it records the engineering data manager, one tag has been created. Okay, so I will go into this and let's review the model first while the PNID is loading. Okay, I think I need to load it. Okay, so while it is loading, apologies, I need to switch back and forth to a different application. So for us to maximize our time, so I will switch back to the PNID now. Okay, so I am opening right here a very simple PNID of a water project. It's a wastewater project. So the interface of the PNID looks like this. So it's a CAD based application. It's not an object type. So some of the PNID or the intelligent PNID are object based software where they are in a database platform. But in this kind of software, it is a CAD based platform where each of these component, they are CAD components, but they contain the engineering information. So I'll just go and show it to you right here. So by looking into this specific tank, I call it the digester tank. So you can view the tag information. You can view the different parameters or the physical graphical parameters of it. Then if there are design properties, you can put it them right here. So basically this is the concept of this software. Okay, so going to the pipeline. So if we have a pipeline right here or a pipe run, we can tick it and view the information of that pipe segment. And then we can also review the parent class of that pipe segment. So I just tick right here. I just select the major pipeline. So this is the pipeline where it has a child class of a pipe segment. So when we are building, for those who are not familiar with PNID, so normally the structure of a project, structure of a piping system, it starts with a piping network system. Then the child class of that one is a segment because you can have multiple segment in one piping network system. Okay, so currently this pipeline doesn't have a multiple one. I only have one, the pipe run right here. Okay, then you can see the information. You can change the tags right here. You can add additional information as well. Okay, so this is a little bit of an overview only. So for the pump, I can pick it up and then I can see the tag information right here. So the interface looks like this. So the different disciplines is positioned in different tabs. In right here, you can see the equipment has different galleries for every specific symbol that you want. So they are all ready for use, and then they are also customizable to your um, specific kind of symbol. Okay, so you can switch to another discipline for piping, then you can put the specific piping component right here, as well as the instrumentation symbols. Okay, and then as you notice right here, we have this plant site ribbon group which allows you to synchronize the information that you build in the PNID drawing, and then you can synchronize it in a bidirectional way. You can do it from the drawing to the database as well as from the database to the drawing. So we will do it in the next part of this in the session. Okay, so if there are any questions, please just comment on the section, comment below so that we can review it. And also, Nelsie, if I didn't get the attention of that, please, yeah, call my attention. Okay, so this is the overview of the PNID. So right now, let's do something in the PNID. Um, So I have a pin ID right here, which is connected to another pin ID. But for now, I will just go on and open another pin ID which I prepared for this session. Okay. So because this is a water project, so it doesn't contain too much details or instrumentation details. So it's a very basic type of pin ID that I created for workshop or demo purposes. So zooming into this position right here, I want to place another pump and another motor, then a pipeline that is connected to this to the two ends of the reducers. So just for you to understand the workflow. So when you are using or first time you use the OpenPlan PNID, so this is what you need to look for, which is the standard preferences. Okay, so in the standard preferences, basically you will define the default parameters or the default parameters in a component where you specify the pipe material class or the specification of that kind of component, then the type of end condition. So whether that is a butt weld end or a flange end, or you can also specify the blank there. Okay. Oops. Sorry for this. I think I need to switch back and open my preferences. Give me a second, huh? Okay, there you go. Okay, so in the plant breakdown structure, you will define the association of your asset or your component. So you define here, I will define the WAS service. Then in the plant area, I will place it under 1A area. And then in the unit, I will choose D001. Okay, so basically you are defining the default parameters because each time we place a component, they will be assigned into a specific plant breakdown hierarchy. Okay, so first we place the equipment. So let's switch to the equipment and pump, and let's place our horizontal pump. So I will be using, by the way, Open Plant Products is using MicroStation as the platform or the CAD platform. So basically, the CAD skills that you require here is a MicroStation skills. So if you have AutoCAD skills, you can also yeah, upgrade or upskill yourself into MicroStation. They are almost similar. Okay, so I'll just pick right here and place a position of my pump. So basically, the pump, when we place it right here, we have to assign the tag number. So if you remember that we created a tag in the plant site or the database, so we can utilize that by calling out that tag under the tag browser. So I just click the tag browser and it will open to me the tag browser dialog of the database. Okay. Okay. So I can now look for that tag, or I can also arrange it by the work breakdown structure. So I can look for the under the D001, and I can also look right here. So you remember we created 1A PMP 205 pump. So we can select it right here. We can review the information, and then let's just click OK. Okay, so the information has been embedded now into this component. So we can further like update the additional information right here, and then we can just complete it by clicking OK. Okay, and finally we place the tag automatically right here. We can put it right there. Okay, so we just place an equipment right now, and I'll just complete it with the motor. So I'll just book it right here, and then I'll just assign the motor. So the tag of the equipment, the motor can be customized as well. You can customize the motor tag based on the tag of the equipment. So in this case, I'll just doing it manually. Okay, so we have just placed right now. So and next part that I will do right here is just to place one pipe from this point to another. Okay, so same method is to switch your tab to piping, and then select the gallery of the pipings right here. So there are a lot of specific symbol that you can use right here. And then from the list of the piping gallery, under the gallery of piping, you can choose the template. Okay, so they are the same piping, the same piping network system, but they are showed in a different symbol. So for example, I will be placing this yellow line, meaning that this is a major pipeline. And now I can place the information right here. So I don't have to change the tag number. I'll just put it right here in the number. I'll place 201, and then you will notice the number is automatically updated. So basically, the schemas and the expression that we defined there will automatically update this information if we put or place the value into these different attributes. Okay, so let us define the design conditions now. And I will put here, it's a 100 mm nominal diameter pipe. And finally, I'll just click OK. Okay, so when we are placing it, so just when you first use open plant, so don't be confused too much. Just look into this portion right here at the bottom left side of the screen, and it has the information or the guideline what you need to do. So you just take the first point of the pipe, and you can proceed with connecting to the end point of the pipe. Okay, so looking right here, I just place a pipe, so which is we can review the information now by selecting this pipe and opening the property. So I will review right here. You can see that it has the from information from this pump, and then the information to there was left blank. So there is some setting that we need to set there to connect to the another pipeline. Okay, and then I can review the major pipeline information, which is the parent class of the pipe run, and it will show you the information of that pipeline. Okay, I can further develop my design by placing some annotation. So I just go to the annotation here, and I then specify, bring it to the to the component, and it will automatically take the information of that item, and it will place the tag. Okay, so and now I'll just proceed in adding some fittings. So just for example, the valve. So I can put the check valve down there. So I select the check valve and just pick it there, and it will automatically cut the pipe into two, and automatically add the end condition or the end connection of the pipe. Oops, I think I did not place it correctly, but it's okay. So I'll just pick from the catalog, and then I'll just put the tag number right here, 211, and then just click OK. Okay, so there you go. It has been placed automatic. It has been placed now, and as you notice, because it's an intelligent software, when you place a component, it will automatically adopt the properties of the parent uh, component, which is the pipe. So the fitting or the valve component has a relationship that that automatically uh, gets the information from the parent class, which is the pipe. So it's showing here the design size is 100, and then the ratings and so on taken from the specification, and then the information or the association is automatically captured by from the parent class. Okay, so this pin ID looks good. We don't have to put too much here. So maybe a small instrument, maybe a discrete type of instrument, or a gauge. So I'll just put this one right here. Okay, and maybe I'll just push this one right here. Okay, so it will automatically stretch out when you are changing your model. Oops, there you go. I had an error. Okay, okay, so I think this is fine right now. So I'll just move this one a little bit. I don't want to add too much information in my pin ID. The purpose is for you to see what is the pin ID looks like. I'll just drag it a little bit. Okay, and maybe move it a little bit right further. There you go. So just for example, your PIN ID is completed, then we can now proceed into updating our database. So right here on top is we always look for the update or synchronize to the database because we are a CAD based software. So we need um, to manually tick on these buttons right here to set the parameters. So I'll just put here always ask. So then synchronize manually. So I want to synchronize it manually. So I just apply and then I will just tick on the synchronize button right now. And then we can now sync it to the plan side project. So while waiting for that, and okay, here we go. So this is the dialog that will pop up when you tick on that button. So this is the differencing dialog. So it will differentiate what has been created, what has been modified into the database. It is color coded based on the change here. So you can see the green are basically added information. Then the blue are those modified information. So the red will be the deleted one. So you can also change the status of this by going through with this one. If you want to reject this change, you can reject or you can do or undecide it, do it later. Okay. So I just keep the default there and I will update. Okay, and then I will sync it to the database. So I think that's good right now. It will sync the database now. So it is sync completed right now. Okay, so I will close PIN ID at the moment. And then I'll just go to the Google Chrome again. I want to see the database. So because the database is located in the cloud, so meaning uh, we need to at least refresh our Google Chrome. So I just go to the change set again. Okay, where's the change set? Okay, there you go. And then I will click on these changes and I will look. I will review if, let's see if the changes has been recorded. Okay, so I have now the 301 number, which meaning it is coming from Open Plan PNID. So there you go. So you just tick on this change set and we can visualize that right now. Okay, so before we proceed with the 3D model, so let's wait for a couple of seconds right here to open the visualizer. So I want you to see what is inside the project. Okay, so while it is loading, I will open my 3D modeler. Okay, so let's okay, I don't want to open too many application. I will keep it right like this. Okay, so this is the interface of the visualizer. So you can see there are save views. So I created multiple save views. Okay, and then I can switch to the 3D model where I can specify or I can tick on the specific model. So by the way, the different sources of these models. These are the different sources of the model. It contains a civil, it has the electrical, it has the structural model as well as the building. So I federated it into together into this project. Okay, and I have here the component that I'm creating. So if we are placing a 3D item in our 3D model, then it will be added into the process physical model. So I can also review 2D diagrams or the PNIDs, or if we have 2D views into our models, we can review it right here. So I have 1, 2, 3 PNID. So I'll just tick on this PNID that I modified, and let's see what is inside here. Okay, So exactly what we created in our desktop software. So the pin ID is now visualized in a Google Chrome. So we can now see that a new pump has been placed with a motor, and then we can also see the additional pipes, right? So basically, this is the interface of PlanSite, and it's not just a visualizer; it is also a reviewer, right? Because if we tick on this component, it will open also the property dialog. Okay, so the property dialog is appearing right here. I'll just look into the functional information or the PNID information. And I can see right here the name, the number, then the association. So basically what is appearing here is the only properties that has a value. You can also review the empty values by turning it on, and you can see the different property of this item. Okay, so I can tick on the motor, and then we can visualize the property. I'll just summarize it to see right here. And now for the pipe, so if we have created for this one, for the valve, you can see the information of the valve 211. And then if for the pipeline, I can switch to assembly because a pipe may contain multiple sections. So I will switch to top assembly and tick this pipe right here, and it gets selected all of the fittings that is a part of that pipeline. And now I can see the information of this, the tag, the name, the number, the plant area. So basically, that's how it is. Okay, so I am just showing it to you in the 2D mode. So, but you can also switch your view into 3D by just going to this button. Okay, so I'll just quickly go through, show to you the 3D view of this. So right now I have no layers open. I'll just fit my view. Okay, so there are layers that you need to turn on. You can turn off also the layers or the categories or the levels of your project. So I have some save views right here where I can just quickly navigate to that specific view. So I actually placed this project into the part of C6 area in Rizal. I think it's somewhere in Manila. Okay, so the location of project is right down there. I'll just zoom in, fit view to that location. Okay, so you can see the Bing map is also added just to give me additional information or additional uh, visuals for my project. Okay, so I also added the geo coordinate system into this project. So later on, I'll discuss in the 3D environment mode. So I can switch my view to a specific location that I created to the home view into a specific location inside of the building. You can also always go there, and then I can always go to the surge tank, for example. And I think I created one view just right now. So where the location of the pump house. Okay, so you can see I created a section tool, something like a volume cutter tool where you can create volumes within the working area that you want to work. So, so I just place it right there. So I will later on in our 3D model, I will be placing the a new pump right here. Okay, so that is how it looks like. So what we want to achieve later on is if I fit my view and I will turn on all the models. I'll just remove the section, okay, to see all of the models. So it looks like this. Okay, so the interface is pretty fast. It's only the once it is downloaded into your cache, it will cache, then it will be very quick for us to review our project. Okay, so the what we need to achieve by today is we need to have something like two. to at least see the consistency of the PNID and the 3D model, and we need to view it in a single interface at the same time by just going to the browser, Google Chrome. Okay, so in this view, you can also view the different other views, like your 2D views. If you created a orthographics view that has been saved in this model, you can also view it right here. Right now, I have a PNID that is in my small dialog. I can always switch it back to 2D right here. Then they will switch to the other view. So the purpose of this is when we are doing design review, like for example, I have a tank right here in my 3D. I want to check the properties of this, and I want to check if this is placed also in PNID. So I just tick that, and it will also select into the PNID. It zooms in, and then it opens the property dialog as well. Okay, so just modify it a bit. So I can now easily review the information. So basically the concept of building this is that of building the digital twin is different kind of sources containing the same asset information. So they will be aggregated into that single asset, and then they will create a link to each other. Okay. So even if that is a point cloud data, as long as you put a tag number similar to this, then the system will look into that tag number and it will consider as the same asset. Okay, basically that's the concept of the system. Okay, so I can tick on the pumps, for example, and then we can see. Okay, and it automatically opens another PIN ID for me right here and zooms in. So if I tick on the PNID side and I tick on this pipeline, then it also selects the pipeline in the 3D. Okay, so this is what we need to achieve later on after we place that component in the 3D. So I will go into my 3D modeler now. So our time is yeah, just good enough. So let's go to our modeler. So uh, OpenPlant 3D modeler is another application. So it's another software that you need to install. It's a different interface because it's a 3D interface. So basically, it's the same concept with any microstation based software where the interface, the home page is the same. We used to select the workspace, and at this time, it's the same work set that we use in the PNID. So it's the same WDTP demo number one project. Okay, so I will open this session right here. So I am working in a component-based environment right now. So you can also use this software as a file-based design mode where you don't require to synchronize it to the database. You can keep your models in the file. So so you can also use this one. So when you're launching it, it will automatically detect the connection and create the connection to the database. So the first time, it will take a little bit longer, like a few seconds to establish the connection. Okay, give me a second. So while it is loading, so all of that connection and the synchronization process was created or managed by a specific software of what we call the Open Plan Administrator. Okay, so this is a package that you will get if you have installed the Open Plant Modeler. So the Open Plant Administrator or the administrating software has the features to configure your project, to set up the schemas. It has the schema editor, the tag editor, the specification editor. Uh, all of the settings that you need to set up the project is this is the software. Okay, and also it also creates the connection to the connected project in the cloud. So you can see right here, I am selecting a specific project and it gives me the information of the connected project. So you can see the iTwin file is that name of the project. And then the iTwin GUID, this is the one, this is the URL you get that connects to that specific uh, project or the iTwin file. And then the project ID is there. So that is established in this software. So as also a very good information about OpenPlant also is when you're working in a project where it requires a PNID, a 3D model, or electrical model, or a structural model, or a support, a very complicated support model where it requires the support engineering software. So what's good is you are working in the same project and all of the configuration is the same, meaning it's very easy to work with different discipline, PNID, 3D, because they are all in the same project. Okay, so that's the 3D model. So going back to the 3D view, what's this? It's a section clip. So I'll just remove the section clip. Okay, it's okay. I'll just leave it. That's coming uh, from a reference model. So first of all, the interface looks almost a typical common interface for a 3D modeling software. But the difference is this is a plant application, meaning the galleries of this and the symbols that's available right here is specific for plant design, meaning you can see the different 3D of pipe symbols. The 3D is available right here. You can also not navigate it easily. And then you can also switch to, they are also, um, they're also placed in a specific tabs. Like your piping is right here. The equipment placement or equipment galleries is also placed on a different tab, as well as HVAC, maybe raceways for your electrical, then the supports, then there are some structural also that you can use right here. And there is also the plan site button for us to update the database. Okay, we can also bring in that model from plan site and we can visualize it into the environment of the 3D. Okay, so let's get started. So basically, when we are starting a 3D model, we have to at least reference some information. So the information we get from our civil team, our structural building, or maybe the general layout. So at least we need to understand, okay, how do we define it? How do I start my model? So it's good that the this kind of software uh, can work with or can leverage the availability of the geo coordinate system. So meaning if you want to geography geo locate your models, all your components are coincidentally geolocated, so it's very easy when you are using this feature. So I'm just going to right here in the coordinate system, I place a geo coordinate of this, so where it is placed in Philippines. Okay, so I use this one, and also I can review the location of this location by turning on the background map. Okay, so I'll just quickly turn on the background map. Hold on for a few seconds so we can easily. Okay, there you go. So so MicroStation Power Platform contains this feature for us to easily view the background being mapped. So I'll just switch to top view. So basically that's in the part of Philippines. I place it down there. I look for some vacant area where I can put my plant. Okay, so I can also bring in information now from the different disciplines by just attaching them. So I have attached multiple sources of models. So they are also in DGN format, but they are in the read-only format. We call it the I.dgn. So I can now visualize my civil data by just turning them on. Okay, I think let me just, okay, I can turn on other layout. Then I can see the layout model that was given to me by this the civil team. I can turn on some of the building data. Okay, and I can turn them on. All of them I can turn on, so I can have a full view of my project. Okay, so I am referencing all of the different multidisciplinary models right here. So what helped me in bringing in them together is because they are all in a correct geolocation or the coordinate system. I'm using this common coordinate system for every discipline. So you can see they are placed into the same origin. So all of them, they are not offset into different. So basically, when you are attaching a model, you don't have to move it after. That's the purpose of the geolocating your models. Okay. So now that I have these models, I can now create the views or the save views. I can clip my volume and then I can uh, proceed with my 3D model. Okay, so the 3D model that I place is somewhere located right here. I created a save view to just go to that location immediately. So I created multiple views right in my 3D model. So I just, for example, plant north, then I can go to the membrane pumping station. I can also switch my view to another view outside. And then right here is the pump house where we want to place our pump. Okay, so right here is this is the pump house. Let's place our equipment right here and a little bit of piping. So okay, so the first step right there when we what I showed to you, and so we need to bring in the references, right? We need to bring in the building models, the civil models if needed. If we have other models, then we can also reference them in. So but now I want also to bring in as a reference my 3D model in plan site. So how do we do that? So we can always do that by just going through the hierarchy in our plant explorer in the project explorer. So we have two categories here. One, open plant modeler. It is showing what is active in this model. So basically, it should be empty. That there are some pipes in this model. So and also I can reference what is in plant site. So I just go and pick up the unit D001, which includes the piping and the pipeline. Okay, so I'll just select this unit and I will reference it out into my current session. Okay, so let's see, where did it go? Okay, let's see, maybe it is moved somewhere. Give me a second, huh? Okay, it may be somewhere down. So D001, then pipeline, plan site. So I'll just turn off the rest of this. Reference 4. Then I will reference it again. Okay, it is located somewhere there, but give me a second to just refresh this one. Okay, so let me view it all and then let me refresh my model. Okay, hold on. I switched my view, sorry. Okay, I'm opening a session. Let me check with my other session if it's there. Okay, it's not there. So I'll use this view. I will try to use this view and I will, so hopefully it is showing right there. Okay, so I picked the wrong area. So the area D001 is wrong. I should be selecting the area 1A. Okay, sorry for that. I tick on the D001. Then this should be the one. Let me see. 1A. Okay, let's reference. Okay, then that's good. So I referenced the wrong model. So basically, it's supposed to be I need this model, and I selected the wrong unit. So I'll just bring in now the different discipline. Okay, then I can have a background and I can hide some of the models. So what we need now is to place that pump, right? So right here, let's identify this item. So what we did, we just reference them in, meaning we cannot modify it. So they are locked by default. So they are locked right there automatically. You cannot delete it, but you can copy them and place into your active file. So what we need here is we need to place a new pump, and then I will also connect it into this item. Okay, this T here. So I'll just do the shortcut thing. I'll just select this pump right here, and I'll just copy it. Okay, so copy. I will select the center of this pump, and then I will move it and just attach it and make sure that this is properly uh, placed in the correct position. Okay, so now that we have copied it from the existing model, and now you can see that this is now editable in this active file. Okay, so now let's modify the tag by just double clicking this item. Okay, so we remember we placed that equipment into the pin ID and we reviewed in the plan site. Then we can now browse it again in the 3D model. Okay, so let's look into this one. So the tag browser is providing us, giving us the information about what is placed in the PNID and also what is available for us to place. So we can also see right here that the symbol on the left side, meaning that this has been placed in the PNI 2D document, and the rest, the dark one, were maybe placed in the 3D. They are not placed in the PNID. So I will now select that same tag number. I'll click OK, and now the tag number has been corrected. I can review the other information, and then I'll just accept this. Okay, then that's completed now. So next thing that we place is the the pipe. So I will create the pipe, and then same thing that I do is let's browse that one. And let's just find it. It should be was 201. So let's go back and review that into our 3D. Let's see if that is correct. So in our 3D view, yeah, viewport, then let's review that in our, okay, let's review. This is, okay, that's correct. 1A was 201. So let's go and select it here in our tag browser. And let's review. The information is 100 nominal diameter pipe with the corresponding hierarchy. Just click OK. And then it's good now. The property has been automatically placed. So some design information that we can skip. So let's save it. Okay, so we have created now the pipeline, and that can be seen in the standard preferences. So remember, in the PNID, it's the same standard preferences where we set the defaults or we set the parameters. So when we are placing a pipe, we have to choose the pipeline from the list down here. We want to activate it before we place it. So this is also where we select the piping material class. So the piping material class contains the information or the catalogs of your piping components. Your piping, your pipes, your fittings, your valves, your flanges, your gasket, and nuts, and so on. So those are the specification. And this is where we select also the nominal size or the size of the component. So let's just go ahead and put it right now. And then I'll just click on, let's see, this is a 100 pipe and this is a 250. Let's connect it right here, sorry. So this is 200 pipe. Anyway, we don't have to go and connect there. We just, okay, so this is 100 pipe as well. So let's just go on here and let's select pipe and then pick pipe. Okay, select it from the list of from the catalog list. I'll choose this flange to flange component, meaning it's a pipe with a flange end. Okay, so checking the placement component. This is where you review the type of fittings that will be automatically placed. So you can set auto fitting disable or you can automatically uh, place. You can automate it. So these are some of the settings you review, some information. Okay, and now let's put it now in the nozzle. Okay, and use the microstation AccuDraw now to, okay, where is it? In the, sorry. Okay, yes, press T and F, and now orient it upward, and now snap it into the same height of this pipe. Okay, and what it does is it automatically plays the joints. So each time you place a component from that requires a connecting joint, so it will ask you, or it will automatically select from the catalog. So right now I have three options in the catalog. So I just choose the first one, the stud bolt A307, and then I will continue my routing, and then I will just pick the point, the end point. Okay, so same thing. It requires the stud bolts because I have three options. So each of that will be placed with the stud bolt. Okay, so you notice right here, it um, gives the correct connection. The flange to flange contains a bolt and a gasket. And now this one. And right here, there's a missing gasket, but we can try to fix it by just reconnecting. Oops. Okay, reconnecting this to this pipe. Okay, so this is a pipe coming from a reference one, so it's okay. So, but it's okay. So now we are good. We can continue placing our valves now. So I just pick on the valve. I check valve. Okay, and now I will choose from the catalog is a simple check valve with a 150 rating. Then click OK. And then same thing that we do, we will browse for the tag. Okay, so let's see what's available tag. So you can see it's the V211. We can go to our visualizer and check the tag there and see if it's correct. Okay, so it gives me the tag was okay. Hold on, I will select the element, and there you go. It gives me the functional information. Okay, so it's a V211 from the PNID, and let's go and verify it by clicking OK. It's V211, then just pick it right there. Oops, sorry, huh? Oops, where is it? Okay, so the components is not compatible, so it gives me this error because the catalog or the item that I selected from the catalog is incompatible. Yes, I think I choose the wrong one, but it's okay. I select the globe valve instead of the check valve because I don't have that item in. Okay, also neither of that. So maybe the class 125 or 150. Let's see. Okay, let's just place this. Okay, then put it back. Okay, same error message because there's some rules that is embedded in the software. If the rating is not compatible, then it will not allow us. So, but why? What is the rating of this one? So, but it's okay. At least we understand the workflow. Let's check for the other part here. It could be 250. Okay, it's a 250 pipe. Let's browse for the tag again so that the tag is correct, and then you just place the check valve. So that's the simple graphics of the check valve. Okay, so at least we are good now. We have placed this one, and now we can push these changes to our database. So by just clicking this update button, we will update our database now. So this will be the last part of this tonight's session. Later on, I'll just go through the sample deliverables that I published from this project. Okay, so the same differencing dialog for the new item. So this is where you review that and we synchronize it. Okay, then it's completed now, and now it's time for us to go back to our Google Chrome, and let's do design review again. Okay, so same method. Let's just refresh this tab. So I just go to the latest change set again because there is a new change set. So I can see now Open Plant Modeler is number 302. So I have recorded and done it. So I just select it again. Okay, so while it's loading down there, I'll just go back to my 3D model. And it's time for me now to hide all of the references. I'll just hide everything. I don't want to see them. And also I will remove the references I got from plan site. So just clear the references here. So I can only see my model. Okay. So what I modified. Okay, so let's just review what we can do from here. For example, we will build the isometrics of this. So you can go to the piping network group where you can see the manager. Okay, and then you can use this pipeline manager to generate the isometric sheets. You can also manually pick the items that you want to place in your isometric sheets. So I'll just auto generate it just for this purpose. Okay, it appears to have an issue because there could be some disconnection down there. Okay, so it's okay. So I will just do it manually now. I'll just tick on this item. Okay, select this item and I'll just add it into my ISO sheet. Disconnects has been found. It's okay. I'll just hide you. There's some disconnects. So the disconnects. So I just pick some items. Okay, there are missing fittings. Okay, but it's okay. I'll just pick this part. Okay, there you go. So meaning that there are some disconnects at that area. So this is very crucial when you are a piping designer. So you need to always check the connectivity. So the software will auto detect it for us, and will sometimes fix that automatically. So I'll just skip that option and I'll just save this isometric just for us to be able to generate the isometric. So let's just take the isometric style and just generate this one. Okay, so seems the isometric is hopefully generating there. So let's go back to our browser and let's go to the pump house view now and let's visualize it and let's see if the changes has been updated. Okay, it's available now. So looks like it's not there yet. Oh, okay, it's there yet. It's there now. Okay, so you can see that it is appearing. I'll just show the section handles here. I want to visualize the rest of it. Oops, it's too big, too small. And then there you go. Okay, so this platform acts not just in engineering part, it also helps you in design review because it's a very, very powerful tool. Okay, there you go. We can now see the new pipe, the pump is available now. Then also the pipeline, the same pipeline. I will switch my 2D view now and see if we can cross probe the item. Okay, so I select in the 3D. It gets selected in the PNID, and then the information is now available for us to review. Okay, so basically that's the complete workflow from PNID and 3D. So it's just a process creating a pump, then a pipeline. So let's try for a pipeline. Then okay, let's see if it gets selected in the PNID. There you go. So it has it's in the PNID now. Okay, so let's go to the okay. So it gives me an error in my isometric. Okay, it's okay. That's something that we can control there. Okay, so what else in the plan site is we do have the features like you can perform clash detection. So clash detection, you don't require a desktop clash detection checker for this. So because even in Open Plant Modeler, there is already an available tool to collaborate. You can run class detection tests within the application, and you can also collaborate with the plant site project. If there is an issue that has been assigned to you, you can also manage those issues. You can review the issues. If there are issues that has been ongoing issues, if it's something related to you, you can see the issues that has been placed on this project. You can see, I think this has been closed and there's one open right here where you have to add pump. You can open the issue in your desktop, and then you can review if there's some attachment, comment, and you can review the audit trail. You can see right there. And then if you have modified it, if it is assigned to you, you can also modify it and attach a new attachment, and then you can reassign it, reassign it back to the checker, and then you can also tick the options right here. So it's a collaborative way of working with like open plan site, especially in the design review stage. Okay, so I think it has been closed now. It's okay. So those are some of the additional features. Okay, see that's I just closed an item there. Okay, so those are the things that you may just need to learn, and yep, I think we have achieved our goal today is for you to understand the PNID, the digital way of working with a PNID model and the 3D model. So to end this part, I'll just show you the different deliverables that you can produce from your model. Okay, so I just go right here. So yep, for the deliverables, some of the basic deliverables in a plant project, you need the PNID deliverables. So as possible, you need to make it up to date with the database you have. You need that consistent output every stage of your project. The integration between the 3D model and the analysis is also part of the deliverables, where you may need to export your 3D model to be imported in the analysis tool. So that is one workflow that is very uh, hectic workflow if you are not doing it intelligently, right? So the platform, if you're using a correct workflow, then yeah, it's very quick. You just export a format of a structural format and then import it into the structural analysis tool, and it will automatically draw it for us. Same with the piping. And then the reports, you can do the reports also. You can publish report or generate it from plan side or the database, as well as the in your desktop application. And then the isometrics and the orthographics drawing. So this will be the last part of my session, and I hope you learned a lot today. So before I give it back to Nelsie, I just give you some information that we have some offering to students and educators, where you can have an unlimited access to our licenses if you are part of the students or the teachers, or part of the educators. And then this is the website where you can register your details, the education.bentley.com. So I'll just tick that one. And also, we have the YouTube channel where you can follow their multiple many videos that you can learn there. We are keep on updating this YouTube channel with a step-by-step method, especially for the beginners. And if there are some um, um, related issues that you encounter when using the software, you can always contact me, raise an SR, also check the Bentley communities, and yep, see if there are some available information that you can get to help fix um, your issue. Hold on again. Let's just go back to that one. So I just click this Bentley Education. Okay, it doesn't give me the link. Okay, so this is the Bentley Education for students. Okay, so take note of this. This is the website, education.bentley.com. That's enter that, register, log in or register your account. So if you don't have an account, you can register. So you can also, after you register, then you can just click on this button here and choose the type of product that you want to download. If you want to study something, you can see right here, these are the different available products for the students and teachers. You can see for open plant, so look for this open plant modeler. So this is the 3D application. I think we are only available in the 3D. So please yeah, grab your copy, you try it, and during the download, there's some requirements for you to submit your IDs or your school information or school details. Okay, so that's the okay. Where is my so what's coming next is we are planning for a workshop. So for those who are interested, you can connect with the organizers of this CAD community, Nelsie and Jomar. You can connect with them. So we are planning it, so we can do it in the next session. For those interested, you can join. This will be a basic concept, a basic workshop that I will deliver myself. Okay. So, lastly, thank you for joining us tonight, and I will give the time, yeah, back to you, Nelsie. Hi, Nelsie.
Ayan! Hello, Sir Alvin. So yun, Sir,
Yes.
diniscuss mo paano yung students and educators. So yung mga
Mm.
professional naman natin, do we have a trial link so that they can try the software?
Okay. So for the professionals, yes, you can always also register into the Bentley um, uh, portal. So for the professional, it is the connect.bentley.com. You go connect.bentley.com. I think. Let me check. Huh? Okay, let's see. Okay, so you just type there connect.bentley.com. And then yeah, you it will require you to also log in and register. So it's the same method as the students, but right here is you need to register, and then there once you are registered, there are some download pages for you. You can try. Okay, so if you cannot download, yeah, you can contact me. Okay, so but for the information of everybody, when you are and you have the access to software, we are not giving trial licenses. Okay, so we are giving evaluation licenses for companies that is requesting for it. But you can have a 7-day usage of it after you install. So if you install it now, so it will expire after 7 days.
Next question, sir. Ayan po. What do
Yes.
you think is the rank of Philippines in terms of BIM and construction technologies?
Philippines is always the best, but if in terms of ranking, our skills are one of the best in the world. If I to say, if we're talking about beam, the Filipino skills is very good. But what we are lacking is the workflow. We are good in using the software, but we are not using the correct workflow that beam is introducing to us. So with that regards, I think we are a bit behind when applying beam into our design. Although sometimes there's a misconception about beam where beam is a software. No, it's not a software. It is the information modeling solution, or something like a workflow that you will follow in doing a beam project. Okay, so yeah, we are behind into that NLC. Yeah, but in terms of skills, yeah, I'm very confident that we are very skilled Filipinos. I think Southeast Asia, you can rank it, yeah, very highly skilled in BIM modeling, and maybe construction management as well.
Yeah, so everyone take note. BIM is not a software, it's a process.
Yeah.
Okay, so follow-up question, sir. And if given the chance to revise the engineering curriculum since left behind na nga tayo, no? What are your thoughts? or topics you'd like to inject?
That's a very good question and a very tough one to answer also. Yeah, it's been 20 years already, almost 20 years that I was in college. So I was in uni, so I almost forgot what you have in your curriculum right now, and I'm not updated also. So I think, yeah, I think the introduction of BIM is very. I think it would help the the engineering curriculums. I think um, like although in other regions, BIM has been introduced into the schools and unis, but it's not part of their curriculum. But what's good with those countries, Europe, Australia, US, like that, even India, is they are very open in they are welcoming all of this solution. If a vendor solution, something like us or our competitors, is approaching the schools, they're very open for that, and they always apply it into their they are not adopting they always adopt it, but they they apply it into their like specific project. So they are very quick in learning because they are far ahead of our knowledge of the knowledge of especially in using these tools. um, I think the curriculum we have is okay as of now, but yeah, I'm not really sure, and I'll see how to respond to that answer. But I think it's the message is maybe for the educators. Yeah, just keep it open. Yeah, allow your the students to learn something. Yeah, learn everything. Learn all of the CAD softwares and so on. Yeah, and explore. And there's a lot of opportunity for the engineers if they are skilled in two or more softwares compared to one software alone.
Can you share daw, sir, at least nakalagay sa kanya two. So at least one na lang. Can you share one project you have handled and your lessons learned?
Yeah, there's a lot of project. The every project you will learn, especially professionally, personally, it will just change you right after each of these project. Right. Just to share, we have the largest project I'm working is in Singapore. That's why wastewater treatment project. So I understand Philippines has a lot of wastewater project incoming and ongoing right now. So that's why, yeah, I presented this one. I use my data set. So yeah, the challenge in this kind of very big project. It's not a small project, and the technology is very advanced now. So and also the requirement of the owners and the clients has been also upgraded. So like what we used to deliver in the old days, I just need to model it. Then it's okay as long as I can present it to the client. So not at this stage, that is not applicable now. So the owners and operator requires like it's a full BIM model. BIM means you have the 3D, you have the complete information from construction, from procurement, from construction to the asset replacement until it ends. You need to put it into that item. So that's the requirement of most of the, especially in the infrastructure project, like buildings, roads, wastewater treatments. So that's a tough challenge for the industries now. So that the main challenge is how do we make sure this is a fully intelligent model, and another challenge is because there are different stakeholders in the project. other stakeholders using a different platform, different format. Then we in Bentley is using a DGN format. So that's one of the most challenging part. So that's why it's good if okay we consider one type of format to use for the entire project, because we are not considering for a project stage, but because a project will just end after the end of a project, but the life cycle of that asset will end until like 25 years, 30 years, right? So it's for as an owner, it's very tough to manage the model coming from different sources. So what's good with the new technology in Bentley we have, so this project here, yeah, we understand we cannot really force this matter to use a single platform. Okay, so what we have, that the one that I showed to you, the plan site. So this is a very helpful thing because it can federate different types of sources, federate DWG, federate even the other Aveva, PDMS, Revit, bring it, Ecosim, Open Building, Open Plan, bring them together in one environment, then all of the information is available. So that's the power of the software, although it's a little bit complicated in the structure, but once you started using it, just open the Google Chrome browser and everything will be done right there. So yeah, that's one challenge. The main challenge is federating, working with large model. Okay, so working with large model is also tough. You have 1 gig, 2 gig of model, then you open in your laptop. Of course, it will crash your machine, right? So that's one challenge. Yeah, that's a part of like, yeah, working with different solution, bringing in, importing one model from to another. So that will crush your machine if there are some like 100 of that mod components, and it will sum up the weight of that item like a valve. You pick up a valve from the software you're using, LC. Yeah, that is a very detailed software. So if you bring it into DGN, it will give me 5 MB at least. Unlike I will place my valve in my DGN, it's only 5 KB or 10 KB, right? So compare that. If I have 5 MB, so I will place it 100 times, then I will get 200 or 2 gig already. So it will definitely. It's not the correct workflow. It is a workflow that is workable, but that is not correct workflow in the BIM world, because BIM is as much as possible you make sure that the data is small and acceptable to the software, of course. Right. So yeah, that's the challenges there.
Yeah, from JM. Can you share those or some countries who have high demand for BIM modelers?
Of course. First, Philippines, high demand. Okay, so just look into the project. So when you are looking for jobs now, look for the websites. Just look for the current projects. First for the BAM, mainly in infrastructure projects, roads, airports, like kind of projects. Then you will have an idea which country is building a project that is using BIM right now. Yeah, Philippines is one. We have mega projects in Philippines. Then Singapore, of course. Uh, I think one of the most advanced countries in terms to BIM is Singapore. Yeah, the level here is very high. So then, yeah, outside Singapore, yeah, Australia, Europe, India, even Malaysia and Indonesia is very advanced already in BIM. Yeah, but for job opportunities, yeah, Philippines number one, then Singapore, then outside of Southeast Asia, yeah, Hong Kong and Thailand and so on.
Okay, o yan sir. Are you hiring daw po ba?
Ako hindi ako nag-hire. But my company is, I think we are still open for many positions in Philippines. Yeah, yeah. Please take a look into our website, Bentley's systems. Then look for the job opportunities. So we are still looking for mechanical, civil, electrical, structural, yeah, project management, I think. Then IT, software developers. Yep, let's see. Yep, the door is open for you. Just go and look at our website.
O yun. So after the live stream, tignan nyo na yung website nila, sir.
Yes, yeah, you use keyword Philippines when you're looking Philippines.
How did you end up in Bentley? Can you share your career journey?
Kung all Filipino siguro tayo dito, okay. Pero now
Ayan.
it's just a matter of luck, I think. Luck and of course your my skills. Yeah, my skills was aligned with digitalization. So I have previous project regarding digitalization project, yeah, where we started from the drafting, we converted it into the intelligent and make the whole plant and so on, and bring it together. My background is right there, and also I am experienced in piping and 3D. So I think everything, and of course we are Filipinos, then we are very easy to hire. I think that's one of the advantage we have being Filipino. Yeah, take pride of it.
Yeah, to clarify kay Victor, no, Sir Alvin is in Singapore. Okay, so siguro to last na, sir. Sinabi nyo kanina, 'di ba, to study, no? So any last thoughts or recommendations to all our students who are watching right now who would like to take up or who is taking up mechanical engineering? What
Oh,
can you give some advice to them?
well, it's not really an advice. Yeah, just explaining the experience I have. Maybe that's one thing I can share. Yeah, but just yeah, once you graduated, you graduate, right? You start. Oh, you may not find the right job for you. Yeah, there's no perfect job for na gusto natin. Then very small percentage na makukuha mo yung job mo na gusto. So just stick with that job. Yeah, it's your first job because whatever job you get, right, the first place, you don't end up getting growing old with that job. Yeah, tatalon at tatalon ka pa din, and as much as you can learn from what you have, every every project you work in that job. So yeah, consider it as a milestone of your life, right? So and you don't know what's your future, but during the middle part of your career, right, like if you age around 27, 28, 29, and late 20s, that's the stage na you have like parang stable na yung ano mo, yung paningin sa buhay. Yung gusto mo ng I will continue this kind of career. Diyan mo makikita sa edad na yan. So whether okay, I want to continue a BIM modeler, I want to be a successful project manager, or maybe a field engineer, kung mga ganon. So you can look also like para sa akin, I started as an administrator of a software. So although mechanical engineer ako, pero I'm working with all of these schemas and so on, where something like IT thing. Pero hindi ako magaling sa IT, pero naintindihan ko lang yung structure ng software. So you can look into that side also kasi medyo madalang yung opportunity, but it's a good opportunity din na makapasok sa mga ganun pag may ganong skills kayo. Pero it's really up to you na yung pag-define ng ano niyo, ng career path ng kung saan kayo mas komportable.
Once more, thank you, Engineer Alvin, for doing this for the community. And we hope to see you to conduct another workshop again with us. And yeah, to everyone, we'll be having another training.
Thank
Thank you,
you,
Sir
and
Alvin. Happy dinner. Happy dinner to everyone.
likewise,
Keep
have a good
safe.
night.